I love that you can go and pop up somewhere and you meet so many different people. I've met so many different people since I've been on this truck. It's unreal.
One day I was like, I wanted to do a food truck.
Yeah.
I wanted to be an industry, you know?
We serve sliders and fries.
Sliders and fries.
Yes, we have vegetarian sliders, we have regular beef sliders, we have chicken sliders, and actually it's all really, really good. It's a very quality product, so we use Black Angus beef, grass-fed, very good.
All right. Thanks to Lucas and Troy for organizing the meetup, and pretty excited to be here finally talking about server-side Swift. This talk has been a long time coming, not as obviously shorter than server-side Swift even being possible in the first place. But I work for a company called New Relic. We're in downtown San Francisco, and we're best known for server monitoring products in different languages, about 5. Obviously, Swift is not one of them. But from that, and kind of getting more into the operations space with kind of container orchestration and Docker, I kind of got really interested in this idea of, that's awesome, Swift is open source, we can compile Swift on Linux, we can run server-side code on Swift, on Linux in Swift, and if we have that capability, how do we actually get to something that looks like a reasonable production environment? And that kind of led me down this path of kind of using a simple server-side Swift application, throwing in a container, and eventually using that container in a very, for this simple app, a very over-engineered solution in Kubernetes to kind of scale that in a really interesting way. And that's ultimately kind of what this talk is about and what the takeaway should be. It's a very gentle introduction to using Swift with Docker and how to take that artifact you build with server-side Swift in a Docker container and potentially deploy it on an orchestration platform like Kubernetes, possibly Mesos or Marathon, or another tool. And that's kind of where we'll get to at the end, and we'll show you kind of some performance numbers too. But the original and most important question in the first place was, well, Apple open source Swift. We can now run the Swift compiler on Linux. We can compile it. We have some sort of binary. Now what? And I think by far the most interesting answer for people like myself that come from an iOS background in writing client-side iOS apps that connect to network services is, well, that's awesome. We can now use Swift on Linux to write ultimately a web app that can communicate with our iOS apps and use the same language. And the reason that's really interesting and compelling is this very old idea that's been around forever in the JavaScript community, and it's this idea of isomorphic client-server code. And the idea of an isomorphic application is just a really fancy and overwrought way to say, you know what, you write code for the client, and that same exact code can run on the server. And what we've seen for browser applications written in Node or JavaScript and how those run on server sides, typically in Node.js, although there are even predecessors of Node.js where this idea was still around, Rhino being one of them. But it was, hey, we have this idea of a model between the client and server, and we want to share that state between both, and we have all this business logic, perhaps around validation. We've written that once. Why do we have to duplicate that all over again for the client side? And the idea and all of this tooling, Meteor being one of the better known ones, was that, hey, because the client and the server are written in the same language, we can reuse and increase our productivity as developers. Really great idea, still ongoing, and you see it popping up a lot in that community. And for Swift, that's especially compelling because as people have invested more time in learning Swift, learning best practices, how to write beautiful Swift iOS applications, there's this really compelling idea and hope that that knowledge is very transferable to building backend services. That said, we're still quite a ways away from that. And I kind of posit 3 completely unrelated alternative reasons. The first and most interesting to me one is just kind of fun. It's a new platform. Best practices are still completely unknown. And if you walk into a room of kind of back-end engineers or people that write Java code for a living, this is almost guaranteed to annoy them when you say, I just wrote my back-end in Swift. So this isn't something super serious. I don't think anyone's going to say that even Apple is going to rewrite all their backend systems in Swift tomorrow or next week. But as just a personal Swift fan, as someone who's really enjoyed writing Swift for iOS applications, I think it's a really interesting space to kind of experiment with for server-side applications. So this entire talk has this huge caveat. I'm not advocating write everything in the backend in Swift. I'm absolutely advocating please experiment and hack around with it. And we'll go into kind of the various ways you can use some of the emerging, vaguely new operations technology to make that a little bit less painful. So if you're convinced by that at all, if you want to hack around with Swift, of course, Lucas has the great, awesome iOS project on GitHub. And as of a few days ago, we have about 16 different kind of server-side Swift frameworks. They all have different philosophies and different authors and different numbers of GitHub stars. Whether it's useful or not, I do look at GitHub stars in determining which one to use. But the kind of world of kind of micro backend frameworks has absolutely influenced the Swift world. Things like Express or Restify and Node.js, or if you come from a PHP background, the Lumen framework have absolutely inspired Swift-specific server-side backends. And the really big one, and the one that has some traction and some nice features that I'll talk about in this talk, is called Vapor, which is inspired, not expired yet, from the, we'll see in a few months, from the PHP micro framework Lumen. And to get it started, it's not as painful as you might think, believe it or not. I want to go through the basic Vapor setup. If you get lucky, you can do it in about 4 or 5 command lines, and I'll go through that right now. The first idea is, we definitely want to use Brew. You can install it directly from the master branch of GitHub, but Brew, the very excellent macOS package manager, all of these projects, because they're for Swift and for the Mac, typically have Brew taps. You can just install the binary directly, which makes it pretty easy. The one thing that you absolutely, I mean, theoretically, you could hack your paths and get this working without this tool, but Swift env, it allows you to switch the version of Swift on your command line. Like if you use Python or RBenv, different languages have different tools that do the same thing. It's very much inspired from those tools, but Swift env gets you to the same place. It allows you to have this nice command. It allows you to switch the version of Swift you're using on the command line. And the reason that's so critical and so important is it's almost guaranteed that the version of Swift you have installed on your command line will not match the version of Swift that the framework was written in. And getting that working is painful. This tool helps, highly recommend it. So you've got that installed. The next thing is to actually install Vapor. And kind of taking a page from other language frameworks, they have this really nice command line interface, or CLI, that creates this Xcode project scaffolding. So you do Vapor space new and the project name. The project name for the rest of this talk is Hello Swift, which is just their very basic kind of hello world and demos some features of Vapor. It does a good job of showing what's possible, but pretty straightforward and kind of gets you started with some code. So Vapor new Hello Swift creates a Hello Swift directory. You've got an Xcode project, and you can actually start building from that point, all from the command line. One caveat, as of 2 days ago, as of yesterday, the Xcode project was a little bit broken, but worked great from the command line. As long as you don't try and build from Xcode, you're good to go. As always, this tooling's pretty immature, still a lot of things being figured out, but assuming you have the right version of Swift installed that matches the version of Swift Vapor expects, which is, of course, a Swift 3.0 development snapshot from late May. You can use Swift env to install it if you don't have it locally. And Swift env uses this really cool idea. If there's a .swift version file in the directory, it'll actually tell Swift env to switch the version of Swift in that directory to the thing it expects, which is really important because then when you type Vapor build, which is really just a wrapper around Swift build, it'll actually compile and work, and you won't get weird syntax errors because the version of Swift on your command line doesn't match the version of Swift that's installed. And one caveat about that, in Xcode, in Xcode 7.3, you can now switch the version of the Swift toolchain in the menu. That does not apply to your command line. So you kind of have to jump through in a few extra hoops. But anyway, long story short, if that actually works, you have Vapor installed. It created this project scaffolding you called Vapor Build. You've installed SwiftEnv. It works. There's a .build directory. If you did it with debug symbols, it's in debug. And there's this binary called app. And if you run app, it'll start listening on port 80. You go to localhost port 8080, and you've got this nice kind of slick Vapor demo. And it's actually using HTML templates. It can convert a Swift dictionary to JSON. It even has some basic session support. And if you come from the JavaScript world, it supports mustache templates. So it kind of has all those features you check off for server-side frameworks that you would know from other languages. Super cool. And kind of once you've gotten past that initial hurdle of just making sure that the version of Swift you have configured in your command line matches the version that Vapor expects, you're pretty good to go. And getting to like this on your local dev machine, not super awful. Unfortunately, you kind of get to this point though, you have it working locally, and this applies to all server-side projects, and you want to get it kind of production ready, something that's reliable, that runs in production, and it's good enough to get maybe several hundred people using, and it's not going to just fail randomly. And that still remains a very, very difficult path. And so the big question is there anything we can do with the existing kind of operational tool chain that'll make kind of getting from this slide to something that's production ready a little bit easier and more reliable? And I think one really interesting development of the past few years is just containers. And we'll get into that, what that means. But I think in this context, it's how can we use container technology, specifically using Docker, to take that Vapor binary we built, that .build debug app, package it in something so it's kind of ready to scale in different tools, and also be packaged so it's a little bit easier to handle, especially with these different Swift versions and managing that complexity. So brief background on containers. There are different container types, completely separate subject, but we'll use the definition from Wikipedia for Linux containers. And the idea is we want to run systems that are isolated on a single kernel. And that isolation provides different benefits for application developers, but also for operations teams. The classic diagram here, and you see this in almost every like Docker or container tutorial, but we've got this idea of the operating system, and we have these sandboxed applications. But it's not just the application in the sense it's that Swift binary we built, or the Ruby on Rails app, or the PHP app, or the Python app. It's the application that's actually packaged with all of the libraries it depends on. So the really cool thing that enables is you can run different versions of the same app that depend on different versions of libraries. And if you're just running on a single server, you know that kind of managing dependencies where two processes depend on different versions of the same library quickly gets just extremely unmanageable. And with containers, there's isolation between these different applications and their dependencies, so it's a lot easier to manage operationally. And the other important benefit for this era of cloud is that they're lighter weight than virtual machines. So of course, if you like spin up a VMware virtual machine or an EC2 instance on Amazon, that's a completely virtualized server. And containers are a much more lightweight version of that. So instead of like virtualizing the entire server, it just virtualizes a tiny slice that you can bundle all the application and its dependencies in it, and that's isolated from other containers on the same server. The really interesting thing, and kind of where that gets you, is that the developer container you build, the container you build for your development environment, is actually the same thing that gets shipped to production. So this idea of works on my machine, doesn't work in production, that becomes far simpler. And because you're actually building this container that can be shipped around, that enables an easier deployment workflow. You build this container, you can build a container image, that image gets shipped around and it gets sent to whatever server you want it to be in. And so we get to this idea of containers being kind of a better or improved abstraction for modern app development. And you don't really necessarily think of kind of where the app is actually running. You think of it as a container that runs somewhere that can host containers. And we'll get into what that means for Swift next. So we talked a lot about containers. I haven't even used the word Docker yet. Everyone has heard the term Docker. It's kind of all over the place. There's a lot of Docker hype going on. But Docker, now that we've kind of covered containers, is really just open source tooling and a friendly API around all of these kind of Linux kernel APIs and enable containers. And there's a lot of other stuff going on, including this kind of very interesting layered file system that's not necessarily super intuitive, but you can install it on your Mac, on your Linux server, even on Windows experimentally. And they've got a really nice tutorial, and a new beta is on its way that will make it a lot easier for Mac developers. But the idea is that you get your Docker your Docker setup working, and you're able to kind of build these containers and package whatever you want inside of them, including the Swift app we just discussed. And with that in mind, let's talk about it. So we have Docker. We know we have this container technology. How do we take that Vapor app and actually throw it into a Docker application? And to cover one thing, kind of an image building best practice. So in order to ship this Docker, in order to get Docker containers working on production, we need to build an image. And an image is a snapshot of the container environment, and that's an artifact that we can actually ship to remote Docker hosts. So one of the better practices around this is to have this idea of a base image, which is the runtime environment. So for Swift on Linux, we've got Ubuntu, we've got Swift, and we've got the various dependencies that Swift needs to actually run on Linux. Separate from that, we've got a different image that's the actual Swift app itself. And that's compiled using the Swift compiler. It creates a binary, and then it runs on that runtime environment. The really cool thing for Swift and the Docker community in general is there's the Docker Hub. So thousands of different types of Docker images, and one developer has actually already created a Swift Docker image. And this mirrors the latest development snapshot of Swift, typically a few days behind. But if you pull down this image and you run it locally, you basically have the full Linux Swift toolchain for Ubuntu, and you can run it on whatever Docker host, whether it's a Mac, definitely not Windows, but you have this container that's kind of just ready to accept your Mac application. And all of these, and the Swift Docker image is defined in a Docker file. And if you kind of look at the Docker file, and that's basically impossible to read, but all it's doing is it's pulling down the Swift toolchain from Apple, which is built for Ubuntu, and it's also installing the dependencies. So it's just kind of creating the generic Swift runtime environment, and the very last thing it does is it runs the command swift -- version. In this case, it's pulling down that version of Swift that we had to use to build the Vapor app, 326-A. And so we have this Docker file, we create an image, and that image is then able to run that Vapor app we created earlier. We get to the next image we'll create. So we talked about this kind of best practice of separating the runtime image versus the application image itself. And this is really straightforward. This is just taking that Vapor application we built. It's adding it to the image. It's running Swift build, which is actually taking the Vapor project, building it, creating that binary in the .build directory. And the last thing it does is just runs the application and exposes port 8080. So if we actually build this image, and you build an image using the Docker build command, there are a lot of options, but it's not that bad to follow. So we have an image described in the Docker file. We'll build it, and -t actually tags it. So the idea is, as you develop, you want to create images with different version tags. So in this case, it's the first time we built a Swift Docker image. So it'll be at version 1. The dot says to build the image in the current directory. So that means we now have an image of our Swift Vapor app. Then we have the image, let's actually run it. So let's actually execute it and then see what happens on port 8080. So in this case, we're going to run Docker. And because it's a web server, the -d is the daemon option. And we're going to run it on port 80. And we're going to give it the image name, which is just the tag we created. It's hello Swift with namespaced with your Docker Hub username, version 1. And if you go to Safari or if you curl on port 80, you'll actually see a response from the Vapor web server, which is really, really cool. It's interesting to talk about Docker. It's like, yes, why did we just kind of go through all of this trouble? Like, why not just run it on Heroku? And the really neat thing that this enables is after we've kind of built this image, we can take that Docker image and run it in a lot of different environments. That Docker image we create is super portable. And it's also compatible with some really, really advanced kind of container orchestration tools that allow you to scale it up to a really, really, really big size. Basically using similar tools that Facebook and Google are using. And so with that in mind, the next part of the talk is really kind of what happens when we take this SmithClay Hello Swift v1 image we've created and actually use it in one of these fairly complex tools that allows us to kind of orchestrate these containers. And this is kind of Swift at fake scale. So kind of using Kubernetes, which I'll kind of go into that shortly, will take that Docker image we created, deploy it on Google servers, and actually kind of use their very advanced infrastructure to kind of scale it up using just a couple commands. So a couple just notes about Kubernetes. Kubernetes is, it's an open source project. It has many different contributors, but it's absolutely originally a kind of a Google project. And if you're interested in like getting deep into Kubernetes, Google recently wrote this really interesting article on ACM about what their experience is using containers for 10 years. Like, what did they learn from that and what systems did they build? And Kubernetes ultimately kind of came out of their basically very, very long experience of using containers to deliver applications. And the philosophy of Kubernetes is, nowadays, you don't build backends on just one server. It's dozens of servers, it's hundreds of servers, it's possibly thousands of servers. But we know that kind of managing even simple applications like Hello World and Swift with thousands of servers is extremely complex. So the idea or motivation behind Kubernetes is kind of an easier abstraction. So someone that builds applications can actually reach a very, very kind of advanced and very scalable system without really worrying about the really intricate details of building distributed systems and data centers around the world. And all of that's like a very grand idea, and we'll get into kind of how to set it up in Google Container Engine next. But that comes with the full admission that that this is absolutely overkill for like Hello World that's going to be used on your local development machine. But I think it's really important to discuss because as we build kind of more complex backend systems and as Swift maybe is a part of that full system, it's interesting to kind of think about like, well, how does Swift fit in or where does it fit in the first place? So Google has basically hosted Kubernetes. It's called the Google Container Engine, which uses Kubernetes. There's nothing to stop you from running like Kubernetes on your laptop, on your own data center, on AWS, on Azure. These different kind of cloud companies have their own ideas behind, well, great, you've kind of taken the leap of faith for Docker. You've put something in Docker. Maybe it's Swift, maybe it's Go, maybe it's Java. How do you manage that overall like complex system? And for Google, they make it pretty easy to get started. So we have that image we built using Vapor earlier. We're going to build it again, but we're going to give it a different tag. We're going to give it a tag that goes to GCR.io, which is the repository for Google containers. Sorry, Google Compute containers. And we build it, we push it up. It's not dissimilar to pushing to a remote GitHub repository. You build and you push it. And then if you go over to the Google Cloud Platform page and you look in the registry, you'll see that image, which is that binary of your actual Swift application. So it now kind of lives in the Google Cloud and it's ready to be configured with Kubernetes. And the first step, and this can be done in the command line too, if you've used any of Amazon Web Services, I think you'll think the UI for GCEs pretty decent. But you create this Kubernetes cluster, and in this case we'll call it Hello Swift. And the cool thing is you can make this cluster just extremely beefy. You can say I want 10 CPUs, 2 data centers, and the memory will start scaling up. So by default, you get 3 CPUs and 12 megabytes of memory, way overkill for just a simple single Hello World Swift app. But you can kind of see the power of using this platform to create a very scalable system. So you've got your cluster going. Next up, you'll create a pod. And pods run in Kubernetes clusters, and pods are just a collection of kind of associated containers that are co-located. In this case, it's a really simple, not interesting pod. One pattern you see a lot is you have your main application, then you might have another container that handles logging. And you group those together as kind of a discrete unit that get deployed together as a pod. This isn't particularly, if you're using the kubectl, which is just kind of the Kubernetes CLI. You kind of have to prime it with your Google Cloud credentials. You can do that with the Git credentials. So that kind of sets up kubectl, and then you'll actually take that image we created, v1 in this case, and create a pod. In this case, we're going to do kubectl run. Very cool. You've created a pod, whatever that is. And then you're going to expose that to the outside world. And you do that by kubectl expose deployment. And that'll actually put a load balancer, just kind of the default Google Cloud Compute Engine load balancer in front of that pod. And you'll able to actually get an external IP and actually see it. It takes a few minutes to assign the external IP. But then if you call kubectl get services, you'll get the external IP, and believe it or not, you get that same kind of Hello World and Vapor in Safari on that remote IP. This probably seems vastly over-engineering, like a simple Swift app. But, and that's totally valid. But the really interesting thing, much like kind of Heroku autoscaling, we've seen different patterns of this before, is you can very easily handle deployments in Kubernetes. So let's say your Swift backend takes off, the app takes off, and you suddenly need more instances. It becomes basically a one-off command line to say, hey, I have this deployment called Hello Swift. I want to create 4 or 40 or 400 replicas of it. So this idea of scaling it and making more backends available becomes pretty easy. This is really just the absolute tip of the Kubernetes iceberg. It gets super advanced. It's still relatively new, and there are a lot of different interesting features. But the idea behind deployments in general is kind of providing this very friendly abstraction relatively for developers to say, if I want to do a rolling deployment, or if I want to deploy a new version to 20% of kind of my VM resources, they try and make that as easy to understand as possible without having to kind of write, a 400-line deploy script. It's kind of all built into the platform. So Google calls it kind of this no ops, which I mean, it's kind of interesting. I don't think it absolutely does not like kind of get rid of operations people. They're still very valuable, but it absolutely simplifies this idea of, hey, I have this container. I want it to go to some generic infrastructure, and I want to use this this kind of abstraction layer to make deploying it as easy as possible. Which kind of brings us to the interesting bit. Like, well, we wrote the Swift app. We put it on Kubernetes. How does it actually do? And benchmarking is really hard, and there's lots of bogus data out there. This is not a scientific experiment, so take it with a grain of salt. But on a Kubernetes cluster, which is hosted in Chicago, 4 instances. Kind of how does Swift actually do? Time per request. So hitting the cluster with 100 requests, 10 concurrently, not bad. I mean, 137 milliseconds response, not too super terrible. And the really interesting thing, if you're not a Node.js fan, you might think this is funny, but it's basically on par with using Node. So if we take that same container, instead of using the Vapor image, we swap it out with Node.js. It's pretty much the same. I know those numbers are really hard to read, but 14 milliseconds per request versus 13 on a kind of a Vapor Swift app. This is not at all me saying, dump Node.js for Vapor on Kubernetes, but it's an interesting starting point for like kind of the discussion of, well, how are these apps performing in something of a quasi-real production environment. So kind of lessons learned through this process, kind of going through the Vapor install process, taking that, making it work in a container, and then kind of taking that container and saying, well, what happens when we throw this in Kubernetes? How do we even begin to get performance numbers on it? I think a takeaway is that containers, particularly using Docker, are really great for portability across different environments. Whether that's the Google Cloud, the Amazon Cloud, or even like just your local development environment. We saw with Swift, like really early on, that one of the challenges was just getting the right version, the right development snapshot version of Swift, like installed and configured, so you could actually even build the project to create the server binary. By kind of encapsulating that in this sandbox container, that becomes a lot less painful, because instead of kind of worrying about the version on your local laptop and what version of Swift it's running and using SwiftEnv to make sure it's correct, that all gets kind of thrown in a container, and that's very much locked down. So we get to this idea that the container really hid the complexity of deploying server-side Swift. And whether you use Kubernetes or something else, I think that gets it kind of one of the core values of Docker and using containers. It's that we're using this kind of hosted cloud thing called Kubernetes that has no conception at all of what's running in the container. It's just code that executes and outputs some HTML and JavaScript and CSS, but it's ultimately a Vapor app that didn't even exist 4 months ago, and that's, I think that's pretty cool and pretty powerful. That said, I mean, as you saw through this talk, kind of getting from hello worlds on dev to getting to like something you can scale and go nuts on with Kubernetes is really overkill. There's not only a lot of configuration, but like just the number of abstractions you have to learn to get there is pretty considerable. I mean, if you don't know Docker, you kind of have to familiarize yourself with what is the Docker model? What is a layered file system? What is a container? What is an image? And then to even like make the barrier to entry more difficult, it's then I have a container, how does it work in some sort of container orchestration tool to take my container and kind of scale it for me? That kind of adds even more complexity. And to make things a little bit even more discouraging, we didn't cover like any of these kind of production best practices like security, logging. There's this idea of health checks. So like, how do you know the application's healthy, it's not failing? How do you know when to restart? There's a lot of discussions about kind of self-healing applications, like Kubernetes can automatically restart a pod or scale up or scale down depending on different conditions. So much more not covered. So I think ultimately it's definitely a really fun project. There's nothing at all stopping you from using Swift in containers, even taking those containers and putting them in AWS or Google or Azure, or even like rolling your own. But we still have a really really long way to go before someone gives a talk that says, hey, here's bulletproof Swift in production. We're supporting 100,000 users on it. Happy to answer any questions at this point, with the full disclosure that I am not a Kubernetes or Docker expert, so I'll try my best. But without any questions at that point. Yeah.
How would you rank Vapor against the other server-side Swift frameworks that you looked at? Notably things like database connectors, multi-threading, other server-side things you care about in scaling an application.
I think for purposes of this talk, I absolutely chose the kind of the most straightforward framework, and that was just something very lightweight in Vapor that could just be thrown in a container that actually would compile on my laptop, which that was an interesting challenge in the first place. But I think to your point, evaluating frameworks through that lens is extremely important, and I think if you were going through this process without it being kind of a toy or experiment, you would absolutely want to get very reasonable benchmarking numbers on, how does this framework behave at scale? Like, does it have memory leaks? Is it throwing up a bunch of zombie threads? So, and I think that gets to kind of a deeper question of how do we monitor Swift apps in production? How do we even profile these things in the first place? And that is very much an unexplored area, but I think we'll have to get there. So really, really great point. Anybody else? Oh yeah.
Can you just speak a little bit to, in your simple example, you had this like a V1 conversion, just as far as like what someone would do in like a Docker container as far as versioning in a slightly more production environment setting.
Yeah, so I've seen different patterns. I guess you would probably, in an ideal world, you tie it to kind of what your personal release process is. Like, one pattern I've seen is people version through git commit SHA, so you can actually tie it directly back to the code. I think if you're not deploying very frequently, if you're doing something like weekly or bi-weekly releases, I could see where maybe you could get away with kind of an incremental release, like this is release number 1, 2, or 3. But there are different patterns, and the best I can say is it depends on how often and how you or your team is releasing. But I believe at New Relic we do use we do use a process that doesn't integrate the GitHub SHA. The Git SHA, yeah.
So have you tried to connect to any backend services like databases with Swift?
I have been too terrified, to be honest.
I guess everything that's REST is okay. So
yeah. I mean, I think I think that's absolutely the next step, right? I mean, when we talk about back-end services or server-side apps, it's not particularly interesting without some sort of persistent store. And I haven't I haven't experimented much with kind of the database connection story. Have you taken a look at any of that? Or okay, yeah, it should be interesting. But I think, at least initially, for some databases that there are different like tools and kind of RESTful wrappers around Postgres. There's one written in Haskell that's named escapes me, or like things like CouchDB. We're actually interacting with the database just over HTTP. So potentially an easier path there, like you said, yeah. And as far as like how to do that with scaling it in Kubernetes, maybe ask me in 2 years. Awesome. Well, hey, thanks very much again. I'll try and post these slides really quickly on Twitter and maybe on the Meetup page too. But otherwise, thanks again. Yeah.